For decades, we've considered the moon a dead, unchanging world. But Chinese scientists just shattered that belief with a discovery that could revolutionize how we explore our cosmic neighbor. Using high-resolution satellite imagery, researchers have detected 41 new landslides on the moon's surface since 2009. But here's the shocking part. These aren't caused by asteroid impacts like we expected. They're triggered by moonquakes from deep within our supposedly dead satellite. Today, we're diving into what this means for the future of lunar exploration. Chinese researchers analyzed 562 pairs of before and after satellite images, each with resolution better than 1 meter per pixel, covering 74 unstable sites across the lunar surface. What they found was remarkable. 41 fresh landslides occurred in 14 years. These lunar avalanches typically measure about 1 kilometer long, 100 meters wide, and surprisingly shallow at just 1 meter deep. While that might sound small, we're talking about roughly 100,000 cubic meters of material, equivalent to about 40 Olympic swimming pools of lunar rock and dust sliding down mountainsides. But here's where it gets exciting. Moonquakes might actually be more dangerous than earthquakes of the same magnitude. On Earth, water and rocks helps absorb seismic energy. But the moon is bone dry, so seismic waves lose energy much more slowly. This means moonquakes can shake the surface for hours instead of minutes, potentially causing much more structural damage to any future lunar habitats. Apollo astronauts first detected moonquakes in the 1970s, but conventional wisdom assumed the moon's geological activity had essentially stopped. These new landslides prove that the assumption was wrong. Most of these landslides cluster in the eastern Mare Imbrium Basin, that dark patch visible to the naked eye on the moon's surface. This region formed from a massive collision with a protoplanet billions of years ago during the solar system's violent youth. Apparently, it's still not finished settling. The landslides occur on steep slopes between 24 and 42 degrees, crater walls, wrinkle ridges, and ancient volcanic areas. The moon's interior is still active enough to generate these internal quakes. This discovery isn't just scientifically fascinating, it has huge implications for humanity's return to the moon. China plans to build a lunar South Pole station by 2035, and NASA's Artemis program aims for permanent lunar presence. Understanding seismic activity is crucial for choosing safe landing sites. While landslide risk is relatively low overall, future lunar architects will need to avoid steep slopes and seismically active regions when designing permanent settlements. The researchers recommend placing seismometers in key locations to map the moon's interior structure better and predict where future moonquakes might occur. China's Chang'e 8 mission, launching in 2029, will carry a lunar seismometer to the South Pole, giving us real-time moonquake detection for the first time since Apollo. Once moonquakes are detected, satellites can immediately check for new landslides at the epicenter, linking seismic events to surface changes in near real time. This discovery reminds us that the moon isn't the static, predictable neighbor we once thought. It's a dynamic world that's still evolving, and we need to understand its moods before we call it home. What other secrets is our cosmic companion hiding? Only continued exploration will tell.